Well, on the plus side, my presentation should be able to go a little bit short, so we should be fine. All right, so I'm going to give an overview of some of the changes in Kokkos-Kernels since the last time we met in December 2023. So still, in terms of the ecosystem, Kokkos-Kernels is built directly on top of Kokkos core. It wraps a lot of linear algebra kernels and graph kernels. This is the composition of the team. The main changes, we now have Yuichi from CEA, and Ichi Yamazaki at Sandia has also joined the team. In terms of the components, so the things that we support in Kokkos-Kernels, we have, so the main components, the oldest one is the BLAST one, and the sparse ones, we have graph LAPACK and some what we call batched dense and sparse algorithms. These batched algorithms do two things. They do either algorithms that you can call within a kernel that have the idea of a third dimension when you have multiple items. So that's batching items. So think of like tensor of rank 3. But we also have some interfaces that allow you to have batched items that have different sizes, and in that case, you lose that third dimension and you just do like one item at a time. So we're still thinking about how to name these things correctly so that people can understand what the differences are and the subtleties between the two interfaces. And we also have an ODE package, which is still experimental, mostly because I only have one user. So I'm going to say I want more feedback for that package to move it out fully of experimental. Okay, so some of the latest development. We have a lot of work that came from Yuichi at CEA on the batched solvers, so batched LAPACK. So he's worked on the various formats that are supported. The general matrix, which is, as you can see from this picture, just any values possibles. He's been working on the factorization of these matrices and how to solve them once you have factorized the matrix. We have some additional functionalities that actually came out of potentially some refactors just to make the code a little bit cleaner. We have some work on general banded matrix. So these are matrices where you have like the knowledge that only a few offset off from the diagonal, you're going to have actually non-zero values of importance. Again, for the factorization in the solve primarily. This one again also included some utility function like the GER, which is a rank 1 update. Same thing for packed banded function, symmetric, these ones. So again, we're making more and more assumption, and eventually the one with the most restriction is the tri-diagonal, which is specifying the exact sparsity pattern of your matrix. Again, these are, while sparse, they are they are implemented in LAPACK, so they are considered dense. But in practice, as you can see, they're not. Okay, second pretty big update since last time has been performed on the sparse component of the library. We have now pretty good support for the BSR format. So what is the BSR format? It's a sparse matrix, but instead of having single entries explicitly marked in the graph of the matrix, we have blocks of non-zeros. What's a block? It's a little matrix. So for example, if you do multiphysics, you might have a temperature and a pressure in your fluid, and so it's a little 2x2 blocks. You could have velocities in 3 dimension. You'd have like three velocities, get a 5x5 blocks, and I think you get the idea. And so instead of representing every entry in that 5x5 block, we represent that block as one entry, and that allows us to have a more compressed, sparse CRS graph. And that also allows us to optimize the access of these non-zero values, so we get a little extra performance. So we have support for the sparse matrix vector product. We have the support for the overload that does multiple vectors. So if you have multiple right-hand side, you can multiply. We have an SPGEM. We have a triangular solve. We have Gauss-Seidel and ILUK. So I think the only thing in general that we could add that has not been added yet is the support for sparse matrix addition, mostly because there has been no customer so far that requested it, but I think this would be potentially the last piece that we want to add here. So if people are using it and are interested in looking at these algorithms, please let us know. Let us know if you find any bugs in general or any performance issues there. We're pretty happy with this work. Another big thing that came up fairly recently is the new documentation of Kokkos-Kernels. So you can find it here, kokkos.org/Kokkos-Kernels/docs. It's very much more in line with how the documentation is presented in Kokkos Core. We're still working on making a complete parity between the old documentation and that new one. That's why I haven't deprecated the old wiki on GitHub, but this is going to come soon. Like, we're almost there. So again, as I mentioned, we have a unified look and feel. The new documentation is distributed with the library in the source. So if you look at Kokkos-Kernels, you'll see a /docs directory, and it contains all our library. And one of the nice things that it gives us is our documentation is kept in sync with the source. So potentially, if you want, when we'll be at 5.3, you could go back to 4.7, which is going to happen in 4 months, supposedly. And, you'd get kind of a sourced, kept in sync documentation. And we have new GitHub actions that are enforcing that when we make changes to our APIs, they have to be reflected in the documentation. So I will almost guarantee that this will work and that we will actually keep our documentation up to date. Okay, there's been a lot of work that has been done around build, test, and packaging. So build system updates, we're working on making things more uniform in the library and using find package for all our TPLs. It's an ongoing work. It's been done for the ROC TPLs. We are doing it for the CU TPLs as well. We're going to look at some of the Intel TPLs as well. We are going to do a move to a single target without any alias for our build targets. It's going to be called Kokkos-Kernels, and the main reason is to align with what is done in Trinos, so that when you build Kokkos-Kernels as an external package for direct use, or when you build it as an internal package in Trinos, you will, like what was done with Kokkos Core, you will get the same targets. It will feel like the exact same thing. Currently, it's not the case. And we know that this is going to create some friction, so I'm announcing it now ahead of time so that you're aware of it. And we will do our best to have some form of deprecation ahead of Kokkos 5. But not everything is possible with the current CMake. So yes, please be aware of that. Public testing has been done. So in the CI, GitHub Actions, so if you're submitting a pull request, you can see all the errors that are generated by our compilers when we compile the code and test it. We also have nightly GitLab runners. So I added the link where you can find them on my.c-org. We have currently built on ALCF.
Could you try again?
Sorry. Yeah, at ALCF or LCF. So on the 3 backends that we support, CUDA, heap, and SQL. Of course, you have serial, and I guess I should be more diligent and also add an OpenMP backend build as well. But yep, now that I look at it, I haven't done it yet. And finally, we are removing some CUDA package inheritance in our SPAC package. I really do not want you to try to target a specific GPU at the level of Kokkos-Kernels. Please do that when you build Kokkos, because that's where Kokkos is actually able to tell you if you've done something wrong. Kokkos-Kernels, we really don't know that much. We just rely on what Kokkos has done. So this just makes a lot more sense. And so, yeah, please, moving forward, let's try to do that. Okay, I'm going to go through some upcoming work, and I'll conclude. So almost there. So for Kokkos 7.0, we will likely it will likely include the Kokkos View refactor that Damien has announced, and this has some impact in Kokkos-Kernels. So we're currently doing a lot of cleaning up in the library. The main thing that we've noticed is we've been a little bit naughty with how we use extent and strides, where we sometimes have Kokkos views of rank 1, and we're checking the stride for the rank 2 of that view, which of course makes no sense. But Kokkos gently let us do that without complaining and returns some form of a value that we can use and not have such buggy code. But it's UB, so we're going to get that cleaned. And we're going to remove a bunch of deprecated code. So the Kokkos-Kernel library also has its own deprecations, and these are going to go away after 5. So that's going to be in about 6-7 months, I guess, probably in August, if I recall correctly. We are moving the CRS metric object from the Kokkos core library to the Kokkos-Kernel library. So if some of you are using the Kokkos CRS matrix, now that I read it, I don't think it makes, sorry, it's the CRS graph, not the CRS matrix. That's going to move. More algorithm stages in sparse algorithms. So this is a work that we're doing in coordination with the sparse blast effort that's led by Hartwig Hans. And so this is something that we're doing as a community effort with the vendors, and we're trying to have a more uniform feel and look across libraries for the different stages of sparse algorithms. So for instance, if you do a sparse triangular solve, you might want to do a symbolic phase, or at least an analysis phase where you look at the structure of your matrix, and then you potentially look at the actual values, like you don't want 0 pivots in your matrix, and eventually you actually do the solve. And so these stages are kind of different depending on which library you use. So for QSparse, RockSparse, MKL, etc. And that's kind of annoying for us because we're trying to provide the users with access to all these libraries, and it looks like Swiss cheese then in our own implementation. We're like, oh yeah, if you use RockSparse, you don't do that, you do this, etc., etc. Okay. So short-term ideas that we're going to try to work on, so additional batched and bend-in solvers. I've recently discovered that it's possible to use ARMPL without a Fortran compiler, just using the libraries that are shipped directly. So we're probably going to modify a little bit our CMake so that we can do that more easily for our customers, and probably have a GitHub action that does that. Fuzz testing is something that I've been playing with in collaboration with Damien, and we think that there is a good potential for that approach to catch some issues. So for instance, recently we have had some issues in the SVD decomposition, where some corner cases where the matrix is almost diagonal or tri-diagonal were not caught by our unit test. And so we think fuzz testing could help us catch these things. More tensor core support. We'll see if we do that just at the level of Kokkos-Kernels. Once we have something fleshed out, we might talk with the Kokkos core team and see how we can potentially have it in Kokkos-Kernels or Kokkos core. And we're looking at what is called the Ozaki algorithm, which allows you to do mixed precision on tensor core. And mixed precision itself is a little bit of a misnomer. You can even do use tensor core for integers type and recover floating point values out of it. So that's coming soon. And then for the more long-term ideas, I've been looking at the standard BLAS proposal for the C++ standard, looking at the sparse BLAS that I mentioned earlier, automated architecture-based tuning. So when we get a new GPU architecture or a new CPU architecture, try to tune our algorithm automatically using some kind of a tool. And finally, finishing the BLAS layer, which needs rank 2 updates at this point. So I think only 2 or 3 functions still required. Okay, and I think that's it for me. So if you have any questions. Ben?
So do you have an implementation of Ozaki scheme already, or is that something that you're planning to do?
We have some experiments with it. So we have the ability to do it in a very small subset of cases on only one architecture. So I wouldn't say we have a full-fledged Ozaki scheme, but that's something that we want to work toward for next year. But because we're cautious before promising anything. We like try a little bit the first year, a year ahead of having actual work getting done on it. So we don't have like a lot of worry about it, but yeah, it's coming up. Yes.
Any plans for, like, in the short term to have dense gem in the T1P level?
It already exists.
It exists?
Yeah. It's in the batched algorithm, batch dense.
I need it in T level.
Yeah, it's in the batch. So I think I mentioned it when I went over the batch nomenclature. We have two things in batched. We have algorithms that can do either work on a rank 3 tensor, so it's like multiple matrices of the exact same size, but we also have interfaces that allow you to work only on one item of that rank 3 tensor. So it's a single matrix as an input within a team or a team vector or a team thread. So for the full list of all the features and all the levels at which you can implement them, we are updating the new documentation right now because the old one was not very clear. And so that's the actual piece that's missing that I'm moving from the old wiki to the new documentation. And that's exactly why I haven't killed the old wiki. So this should arrive like before 4.7. Yeah. Yes? So we try to support both the vendor toolchain and our native implementation. So it will, across the library, it will depend widely. There are some use cases in which we know that the vendor toolchain are much more optimized than what we can hope to do. And so in these cases, we would recommend to use the vendor optimized version. And there are some cases where our implementation has some potential to be more optimized. When we do benchmarking, we are primarily looking at our own internal implementation because these are the one on which we could detect a regression and actually do something about it. But we do have data on both our native implementation and the vendor implementation, so like the call to the TPL. So for the benchmarking, we don't use like necessarily like fine telemetry within the kernels. We just look at, okay, if you don't want to do a gem, and we sweep across various sizes, we just look at the overall time it takes to execute. So there's no NDA issues or anything. All right, and then I guess break.
All right, thank you everyone. It's now time for break. We'll be back at 10:45.